Okay, in this video we're going to review the final exam uh, for Math 111. This is problem number 1 on the final exam review. Here are the problems. This is to be done without a calculator. We're going to graph an exponential logarithmic functions. We have 6 on the final exam to graph. Here they are for problem 1. Now 4 of them can be done with at the same time because they all have the same basis to them. So these 4 right here, checked in red, we can graph at the same time based upon the same exponential function g of x equal 2 to the x. What I would do to start with is to plot that function. Just plot some values. I'm going to use the basic 5 values actually, basic 5 values that I use for all 2 to the x functions, or the graph of this. I'm going to use 0, 1, and 2, and then I'm going to use -1 and -2 because they're the reciprocals. So anything to the 0 power is going to be 1. So 2 to the 0 is 1, 2 to the first power is 2, 2 to the second power is 4. So these are the reciprocals of the positive ones. So that means that 2 to the -1 is positive 1/2. It's the reciprocal of this one here. 2 to the -2 is going to be 1/4. It's the reciprocal of this one here, of that problem. So I always do the first 3, 0, 1, and 2. And then I also do the negatives of these 2 so that I know they're reciprocals. Now this is what I would start with any one of these 4 that I've checked off. I would start with these 5 numbers to graph. This one actually is g of x, so if we graph this one here, it would be g of x. So we would start off with -2 1/4, which is this value here, and then 1/2, and then 1, and then 2, and then 4. So our graph would have an asymptote at 0. We would generally come up close to the x-axis. We'd bend around. We'd go through the value of 1, and then we would bend up towards, oops, that's a little off, but it would bend up like that towards that function. Okay, so that's 2 to the x power. Now I can use this thing to do all the other ones as well. So if I was going to do h of x equals log base 2 of x, that's just the inverse of the other function. So that just means we reverse the x and y values. So in this one, when we do log, we don't even have to make a new chart. We can actually just look at this chart and reverse it, but I'm going to make a new chart here. So if I do x and log base 2 of x, we just take these values and reverse them. So 0, 1 would be 1, 0. 2, 1 would be 2, I'm sorry, 1, 2 would be 2, 1. This would be 2, 4, so that's 4, 2. And this one would be 1/2, -1, and or 1/4. And then -2. So I always start with this one because it's the easiest one. If I'm going to do a logarithm, then I would just switch the x and the y values and graph that one. So this one starts at it has an asymptote on the y-axis, so it's going to get close to the y-axis because this value right here is 1/4. 1/4 of -2, so it's going to go down to here, and then we'll have the value at 1/2 here at 1/2 -1, and then it crosses right here at 1, 0, and then it's 2, 1, and 4, 2. So this one bends in this direction away from the y-axis, and it goes up this direction like this. Alright, now those are the 2 functions that are base 2. Now if you had another base, you'd do the same thing, base 3, base 4, whatever here. You got a 3 to the x here, you have a base 5 here, so I would start off with those. We're going to do those in a minute. But I always start off with the basic graph this way because it's easier for me to evaluate them without a calculator by just raising it to the power and knowing the reciprocal functions and knowing the inverse. So this one would be log base 2 to the x. Now, the other two functions I've checked off are just translations of this one. So if I just say that this is my blue graph here, I would just translate this amount of functions based upon these things that have been done to the function. So this is going to be moving it up 3, to the left 4, and it will be reflected. So this reflects it. Okay, so we have -2 to the x plus 4 plus 3. So this is a reflection on the y-axis, or I'm sorry, on the x-axis. It's the x-axis reflection. And this plus 4 moves it to the left 4 units. And this moves it up 3. So I would just take the values that I already have here, and then I would just change them by moving them this amount, by reflecting then moving. So I would take this value right here on the graph that I have graphed right here, reflect it right here, so it moves to this point. Then I need to move it 4 to the left, 1, 2, 3, 4, it goes right here, and then up 3 units. So then it would be 1, 2, 3. So it would end up here. Let's see, we go 1, 2, 3. It would end up right here, right below that line. And then the next point, which is this one that's at a half, we reflect. It would move down here. Then it would move over 4, 1, 2, 3, 4, and then up 3 units, 1, 2, 3. So it would be right here at the half. Okay, this point here at 1 would be reflected here to -1. Then we move 1, 2, 3, 4, and up 3, 1, 2, 3. It would go through this point here. Then this point here would be reflected to 2 below the axis. Then we'd move it 1, 2, 3, 4, and then up 1, 2, 3. So it would go right here. And then this last point here would reflect to -4. 1, 2, 3, 4, and then move over 4, 1, 2, 3, 4, and then up 3, 1, 2, 3. So it would go through here. So this one looks like this. It has an asymptote at 3 because of the plus 3 at the end. So its asymptote, this is the asymptote on this one. So x equals 3 is the asymptote because of this plus 3. And it has asymptote right here, right across that line. That's your asymptote. And then it curves down because it's a negative instead of curving up. All right, we're going to do the final one here on this one based upon this translation of the green graph. This translation of the green graph is easier. It's just up 4 units. So this is going to just move up 4 from the green graph. So we just take all of the points that we already have here, move them up 4. So right here we're at -2. You can move it up to +2. We move this one up. It's at -1, so it would be at +3. Right there. This one is at 0, so it moves up to +4. This one moves up. It's at 1. It moves up to +5. And this one's at 2, so it moves up to +6. There. So this graph also still has an asymptote at 0, y equals 0, but it's just been moved up. This is of 4 plus log base 2 of x. And remember, this one was the negative 2x plus 4 plus 3. So we always start with these two functions. I always start with 2 to the x, or the basic graph. Even if I don't have that, and if I was graphing log, I would start with 2 to the x and then do the inverse. If I wanted to graph this function, I would start with 2 to the x, graph the inverse, and then move it up 4. Since I don't have a calculator, I always start with the base function of an exponential because it's easier to work with. Alright, so we're going to do the other two down here on this graph. So if I do 3 to the x, start with 3 to the x minus 1, what I would do is I would start with 3 to the x. And as I said before, I start with the points 0, 1, and 2, and then I do the reciprocals with negative 1 and negative 2. So 0 is always 1. 3 to, or anything to the 0 power is 1. This would be 3. 3 to the first power, 3 to the second power is 9. And I do the reciprocals of these, which is 1/3 and 1/9. Alright, so if I were to graph this, this is telling me move it right 1 unit. Okay, so right 1 unit is what it's going to happen from this. So 0, 1 right here would be moved right 1 unit to here. So I'd start here, but then I know that I'm moving right 1 unit, so it moves to here. 1, 3. Okay, we go over 1 up 3. It moves right 1 unit to here. 2, 9. All right, here's where are we at? We're at 2 here, and then 1, 2, 3, 4, 5, 6, 7, 8, and 9. So we're there, but we're moving over 1 unit to the right. So it's here. It's at 3, 9. Okay, negative 1, 1/3 is right there, but we're moving over 1 unit to the right. So it's at 0, 1/3. And then 2, 1/9 is right here. You move it over to this point here. So we still have an asymptote on the x-axis, or y equals 0, but we've shifted the graph over to the right 1 unit. Okay, so that's what's happened here. But I don't graph the 3 to the x minus 1, I graph 3 to the x and just move it right 1 unit. Okay, now the last one here is this log base 5 of x plus 2. So if we're doing log base 5 of x plus 2, log base 5 of x plus 2, so I'm going to start first of all with x in 5 to the x, because that's what I'm going to be able to do. That's the base I have, 5 to the x. And then we're going to have to switch it over to the logarithm by switching the values x and y. So 0, 1, 2, negative 1, negative 2. This is 0 is 1, 1 is 5, and 2 is 25. And then we have the reciprocals, 1/5 and 1 over 25. So now my log function is going to be 1, 0, 5, 1, 25, 2, and 1/5, negative 1, and 1 over 25, negative 2. And then what we have to look at is what happens to this. What's this doing to it? And that's actually moving it to the left 2 units. So we're going to take all these points that I have here and move them left 2 units. So first of all, I'd go to 1, 0, which is right here, 1, 0. And then we're going to move left 2 units. So it goes 1, 2, it's actually right here at negative 1, 0. So the next one is 5, 1. So we go 1, 2, 3, 4, 5, and up 1, but we're going to move left 2 units. So 1, 2 to the left, it's going to be right there at 3, 1. Okay, the next one I won't be able to graph because it still goes out 25 to 2. We only go out to 10, so it's really close to this one. Then we're going to graph the 1/5, so the 1/5 is right here, negative 1 is right here. So it's really close to the axis. But we're moving 2 to the left. So we go 1, 2, so it's really close to this line over here. And the next one is also 1/25 negative 2 is the way close to this line. And we have to move it over, that's right here actually, 2 units left. So it's really close to this line. So it's going to be something that really close to the axis or the line x equals negative 2. So that line x equals negative 2 is our asymptote, and we're going to get really close to that. We're going to turn really close to that, then turn up and go really quickly to the right. So that's that function right here. But having these ordered pairs from 5 to the x and then working on from there is what we want to do. Each time you do something by hand, I always start with the exponential function. Okay, so that's how you do problem number 1.